morning to all my students. So yesterday we met and we understood how to determine whether a chemical change has taken place or not. So what were the four methods to determine the chemical change? First, there will be a change in temperature, or there will be evolution of some gas, or there will be change in color, or there will be change in state. So the four things we learn, and we learn the examples also. So now today, coming on to the next topic, that how do we represent a chemical change? So if the chemical change is represented symbolically, it is called a chemical equation. The equations which we wrote yesterday. For example, Mg plus O2 gives MgO. So this is what? A symbolic representation of the chemical change. How can we make this symbolic representation more informative? So the first thing is you write the states. For example, magnesium ribbon is solid. So you write a small s in the bracket. Next, oxygen at room temperature is gaseous. So we will write G in a small bracket. MgO is a white powder. So again, it's a solid. So this is how a chemical change is represented, and this is known as a chemical equation. Now, how many types of chemical equations are there? So chemical equations are of two types. First is a skeletal chemical equation. And second is a balanced chemical equation. Now what is the difference between the two? The skeletal chemical equation and a balanced chemical equation. Skeletal chemical equation just represents the chemical change and does not take into account whether the atoms of the elements on the left hand side are equal to the atoms of the elements on right hand side or not. For example, this equation. How many magnesium atoms can you see over here? 1. On the right hand side, how many? 1. How many oxygen atoms can you see over here? There are 2 oxygen atoms which make a molecule, and here there is only 1 oxygen atom. So what information does this give? Is one of the oxygen atom destroyed? No. Because all the atoms have mass, and if we say that the atom is destroyed, that means mass is also destroyed. And what did we read in class 9th? We read that mass can neither be created nor destroyed. If mass can neither be created nor destroyed, that means the atom can also neither be created nor destroyed. Now what does that tell us? That tells us that number of atoms on left hand side should be equal to the number of atoms on right hand side, so that it may become a balanced chemical equation. So a skeletal chemical equation is the one which is not balanced, which we wrote earlier, Mg plus O2 gives MgO, whereas a balanced chemical equation states that number of atoms on left hand side should be equal to the number of atoms on right hand side. For example, we noticed here oxygen has how many atoms? 2, because it is in the form of a molecule. So if we want to make the number of atoms 2 on right hand side, remember one thing, that first of all the entire formula should be put into the box. Why do we put the entire formula into the box? So that inside the box, it means we cannot make any changes. So where can we make the changes? We can only put stoichiometric coefficients in the front of the formulas so that the atoms may become equal. So the only privilege which you have is to multiply them with certain stoichiometric coefficients. For example, here the oxygen atom, there are 2 oxygen atoms and we want to make the same this side. So what can we do is to multiply the entire formula by 2 with the help of a stoichiometric coefficient. This way, the number of oxygen atoms become 2, but then magnesium also becomes 2. So what can be done? Similarly, here also you have the privilege to multiply it with another stoichiometric coefficient. So the magnesium atoms also become 2. I hope it is clear. Now let us cross check. Number of magnesium atoms on left hand side 2. Number of magnesium atoms on right hand side 2. Number of oxygen atoms on left hand side 2. Number of oxygen atoms, if nothing is written here, that means what? 1. So 2 ones are 2. If nothing is written here, that means what? 1. So 2 ones are 2. So the equation is balanced. But this was a very primitive equation. How to balance complicated equations? Now let us understand that. See, the first thing which you can do is you can make a chart. First write serial number. Then write symbol of elements. Then write number of atoms left hand side. And then write number of atoms right hand side. Is it okay? So, there are how many atoms in this equation? 2. So, the first one is magnesium. So, let us write the symbol Mg. Number of magnesium atoms in an unbalanced equation was 1. So, we wrote what? 1. Number of magnesium atoms on right hand side in an unbalanced equation was what? 1. So, we wrote 1 there also. Number of second element is oxygen. So, number of oxygen atoms on left hand side is 2. So, we write 2 here, and number of oxygen atoms on right hand side is 1. So, what do? We write 1 here. And now this picture is very clear to you. Okay, where do we need to start the change from? So, what can we do is we can multiply here by 2. When you put this stoichiometric coefficient and multiply here by 2, so the same thing you need to do, that multiply or keep 2, the stoichiometric coefficient, in the front of this box also. By doing so, what has happened? That number of magnesium atoms have become what? 2. So, make the change in the table also. That now magnesium atoms are also 2 on right hand side. So, what do we need to do? We need to make the change left hand side also. First, the table is going to be clear, and then the equation is going to be clear. So, what do? We multiply here also by 2. If we have multiplied here by 2, so the same stoichiometric coefficient we should put in the front of the box of magnesium like this too. In the few 10 or 15 equations, you need to use this box, and later on you will be very comfortable balancing by hit and trial method in your mind itself. So let us understand a few more complicated equations. How do we need to balance them? See, the next is, suppose we need to react hydrogen with chlorine to form hydrochloric acid. So the first thing which the children need to keep in their mind, that whenever you write the non-metals, you write them with their atomicities. Remember one thing, whatever we did in the reactivity series, that is the series which I told you on the first day, that is Kedarnath ka Mani, आलू जरा फीके से पकाता है, कॉपर और मरकरी ने करी शादी और मनाई सिल्वर, गोल्डन और प्लैटिनम ज्वेलरी. In that series, all are metals except hydrogen, and all are monoatomic. So whenever you write metals, you never write their atomicity, because all the metals are what? They are monoatomic. But whenever you write the non-metals, you write them with their atomicity. So if someone says react hydrogen with chlorine to form hydrochloric acid, never write like this, that H plus Cl gives HCl. No, this is the wrong method. So how it has to be written? It has to be written H2 because atomicity of hydrogen is 2. Atomicity of hydrogen is 2 with Cl2 because Cl is also a non-metal. So Cl2. So it is going to react and form hydrochloric acid, that is HCl. I hope I'm clear. So now we need to balance this equation. See, number of, again, let me go to your level and teach you in the same manner again. Let us put the serial number. The number of elements are 2. So what do? We put 1 and 2. Then name of the elements or symbol of the elements. The first is what? Hydrogen. The second is what? Chlorine. Then the number of atoms on left hand side. Number of hydrogen atoms on left hand side are 2. Number of chlorine atoms on left hand side are 2. And the number of atoms on right hand side, the number of hydrogen atoms on right hand side are 1. And number of chlorine atoms also on right hand side are 1. Now this is a very simple chemical equation, but the thing which I wanted to tell you was how to put word equations into symbolic forms. So what have you learned? You have learned that whenever I'm going to write a metal, I'll put it in a monoatomic stage, and whenever I'm going to write a non-metal, I will write it with its atomicity. So these were the two non-metals and I wrote them with their atomicity. And then the formula of hydrochloric acid we discussed the first day is HCl. Okay, so now according to this equation, the simple most thing which we need to do is put them into boxes. Now, if you put them into boxes, what do? We just multiply by a simple stoichiometric coefficient, that is 2, so that the number of atoms become equal. So in the table also we multiply by 2. If chlorine becomes 2, hydrogen also becomes 2. So you can check, hydrogen is also balanced and chlorine is also balanced. Let us try to write another word equation into a symbolic form. And the equation is nitrogen plus hydrogen react to give ammonia. Now see, nitrogen is a non-metal, isn't it? Because why is it a non-metal? First of all, it is gaseous, and secondly, it is not there in the reactivity series which we did. Undoubtedly, there are reactivity series for non-metals also, but luckily and fortunately, you don't need to learn them this year. So the ones which are not there in the reactivity series are what? Non-metals, except hydrogen. And we know by, as we have studied in class 9th, that nitrogen is diatomic. So if somebody says nitrogen in words, so what do? We write it N2. Then hydrogen, all of you know, will be written as H2. Gives ammonia. Now, if we haven't added this ammonia into our list of important chemicals for class 10th, you can add this to that. And the formula of ammonia is NH3. Right. Again make a table. Serial number, name, LHS, RHS. So serial number is 1 and 2 because we have 2 elements only. Name or symbol is nitrogen and hydrogen. Number of atoms on right hand side are 2. Number of atoms on left hand side are again what? 2. Number of atoms on right hand side of nitrogen are what? 1. And of hydrogen are what? 3. Again put them into boxes like this. Okay. So now what is the suitable coefficient to make this 2 and 3 equivalent? So the suitable coefficient is, if 3 is multiplied by 2, then it becomes 6. And if this 2 is multiplied by 3, then this will also become what? 6. So we are going to multiply like this. So we will multiply this 3 by 2. Now where is this 3? This 3 is in this box. So the entire box will be multiplied by 2. Where is this 2? This 2 is here in this box. This symbolizes hydrogen. So this entire box will be multiplied by what? 3, and the same will be mentioned in the table too. Okay. So now number of hydrogen atoms on left hand side are also 3 into 2, that is 6. And number of hydrogen atoms on right hand side are also 2 into 3, that is 6. Now who is unbalanced? Nitrogen. So if you check out, when we had put this 2 here, to balance hydrogen, nitrogen also became what? 2. So make up with the changes in the table also and multiply here with this 2. Now just check out your table as well as the equation. So what will happen? Number of nitrogen atoms on left hand side 2. Number of nitrogen atoms on right hand side 2. Number of hydrogen atoms on left hand side 6. Number of hydrogen atoms on right hand side also 6. So now this equation is balanced, and you can see the equation also for cross-checking once again. So today we did simple techniques to balance a chemical equation of simple chemical equations. Now I'm going to send you a worksheet in which you'll try balancing the simple ones, and tomorrow we are going to do the complex ones. So stay tuned till tomorrow and have a good day.